Hi there guys, hope you're doing well. This is your friend and tutor Manas. So let's see what this problem has in store. Here we go. So this is the figure in front of us and this is the point O, which is being pulled in four different directions by these four forces F1, F2, F3 and F4. What we need to do is we need to find the resultant of the coplanar concurrent forces acting at the point O. How can that be done? Well, let's start. We know very well that the resultant is given by this formula under root of summation of say all the forces in x direction plus summation of all the forces in y direction. Okay, and what we need to do is to be very specific. I'm going to be resolving all these forces in the x direction. Okay, and then I'm going to sum them up to get this value, summation of f of x. And then similarly I'm going to be resolving all these forces f2, f1, all these forces in the y direction, and I'm going to get this value, summation of f of y. How can that be done? So let's start with this one, 150 Newton force. Okay, so it's going to have two components. This is going to be 150 cos 30, and over here one more component, 150 sine 30. Similarly, this 200 Newton force is again going to have two components, one towards the left hand side. This is going to be 200 cos 30, and above it's going to be 200 sine 30. Let's have this one, 80 Newton force. It's going to have one component in the negative x direction. This is going to be 80 cos 60, and in the bottom direction it's going to be 80 sine 60. Okay, moving ahead, we have this force 180 Newton. All right, so it's going to have again two components, one in the positive x direction. This is going to be 180 cos 45, and the other one is going to be in the bottom direction. Let me do this, 180 sine 45. Okay, right now I'm going to be putting all these forces over here in the form of an equation. Well, there is a rule that needs to be followed. You have this coordinate system. Any force towards the right hand side shall be taken as positive, and in the upward direction shall also be taken as positive, whereas the force which falls towards the left hand side, or which is directed towards the left hand side and towards the bottom, shall be taken as negative. Okay, so let's write them down. So we have these two forces towards the right hand side. Okay, so they're going to be taken as positive, and these two forces, these are directed towards the left hand side, so they are going to be taken as negative. So let's write them down. 150 cos 30 plus 180 cos 45 minus 200 cos 30 minus 80 cos 60. And when you put in all these values in a scientific calculator, you're going to get this 43.98 newtons. Okay, so this is the value of summation of all the forces in x direction. Now let's vary about all the forces in the y direction. You can clearly see that these two forces are directed upwards, so hence they're going to be taken as positive, whereas when you speak of these two forces 80 and 180, these are directed downwards, and hence they're going to be taken as negative when you write them down in an equation. Okay, something like this. So 200 sine 30 plus 150 sine 30 again minus 80 sine 60 minus 180 sine 45. Okay, when you put in all these values in a calculator, you're going to get this negative of 21.56 newtons, again approximately, okay, to two decimal places. Okay, what we're supposed to do is we are supposed to get this value resultant. So we have, again over here we have summation of f of x. We already have this value in the form of 43.98. We have this summation of f of y. We have this value as 21.56 in the negative sense. So we're going to put this up, 43.98 square plus negative of 21.56. well, negative is not going to have an effect as it's going to be squared up. Okay, so when you put this up in a scientific calculator, you're going to get this value, 48.9 newtons. So you can also write this as approximately 49 newtons, okay, to be very precise. So the overall effect of all these forces is going to be 49 newtons. Or you can also say that if you want to replace all these forces, F1, F2, F3 and F4, you can replace that force, all these forces in fact, with one single force which is equivalent to a magnitude of 49 newtons. Okay, now let's go ahead and let's find the direction in which this force is acting. So tan theta is equal to summation of all the forces in y direction divided by the summation of all the forces in x direction. Basically, why we are doing this, let me show you why. Let me use this space. We have this f of x, summation of f of x, and we have this as summation of f of y. So if you were to make a force triangle through this, and okay, and here you're going to have this resultant, you can do this in this way. So this is going to be again summation of f of x. Above you're going to go parallelly, so this is summation of f of y. Okay, summation of f of y. Okay, then the resultant is going to be over here. This is going to be r. The resultant makes an angle theta. And if you try to use trigonometry over here, so tan theta is going to be perpendicular, that is summation of f of y upon base summation of f of x. So it's going to work out as over here, f of y over f of x. So when you put in these values, f of y works out as negative of 21.56 over f of x is going to be 43.98. When you put in all these values, you're going to get tan theta as minus of 0.49. Okay, and when you put this, theta equals to tan of inverse 0.49, you're going to get the value of theta is equal to negative of 26.11 degrees. So guys, that was all from my side for today. I'll be back with more such video tutorials. Until then, it's a wrap. This is Manas Patnaik signing off. Take care and keep learning.